So I've never been to Colombia. I've never been to South America. Wow, it's so cool. I just had the best lunch of my life. I'm sorry, that's what made me late. The other thing is that I'm a big cyclist and I watch a lot of cycling. And when I flew into the airport the other day and then went over that mountain and came down into Medellin, I thought, that explains Nairo Quintana. Someday he's gonna win the Tour de France and I'll be rooting for him just like you when that happens. Okay, so I'm Sandi Metz. Thanks again for inviting me. I wrote a book a couple of years ago. Before that, I spent 35 years writing code. I had a day job. I went to my job every day, and I wrote code. And then I sort of accidentally wrote a book. I won't go into why. But when the book got published, it was like a bomb went off in my life. You can imagine. It was, all of a sudden, people wanted me to make talks, travel, and speak at conferences, and they also wanted me to teach. And I eventually decided that I had to quit my job because I was traveling so much, and then I had no way to make a living. And so I finally agreed to start teaching courses. It was interesting that the book caused all of this to happen, and I was surprised by the impression the book made. It never occurred to me that people would read it, right? I did not imagine that would happen. And so when all of these changes started happening, I was trying to figure out what it was about the book that touched such a chord in people. And it was clear to me that I had a different idea about objects than many of the people, especially in the Ruby community, in our community where we tend to be self-taught. And so during the process of making curriculum for the course, I had to go pick a bunch of different ideas about object-oriented design to teach. And I thought that I was picking different ideas, a bunch of different things that I thought people ought to know. And now I've been teaching that course for a year and a half or so, and I realized that all the things I've been telling people, all the different things are really one thing. And that one thing is fundamentally the way in which I think about objects that's maybe different than what you think about. And so I have taken the experience of the last 18 months and distilled it all down into this 30-minute talk. This is what I know about objects and everything you need to know about objects in 500 slides of code. And so if you're in the back, this is a good time to move forward. I promise you, you will hate yourself if you stay back there, all right? You've been warned, all of you. Later, when you get to where you can't see, there's plenty of seats in the front. Just get up and move on down here. Okay, so this talk's in 4 parts. I'm gonna go build up from the bottom, because that's where they come. The first part, the reason I think about objects the way I do is because I'm infected by small talk. I've been writing Ruby code since 2005, and I have not yet written Ruby for as many years as I wrote Smalltalk. Smalltalk taught me how to write object-oriented code. And I suspect that, has anybody in here written any Smalltalk? Do you know Smalltalk at all? Okay, one person. You don't need to know Smalltalk to understand this, but I'm gonna tell you one thing about Smalltalk, and I'm gonna use Ruby code to illustrate it. I'm gonna tell you one thing about Smalltalk that had you learned object-oriented design that way, it would change the way you think about code. All the code examples are Ruby, so do not be afraid, have no fear, okay? You know this, that resolves to 1. Now, you may or may not be familiar with this syntax in Ruby. There's a send method. You can send the send message and pass an argument, a symbol, and then it will invoke the method. So these two things are the same thing. They're synonymous. You know this in Ruby, right? That returns 2. Now, you may not know, however, that you can also do this. You can send the symbol plus to fixnum, passing 1 as an argument, and it will return a 2. Now, what is 1? Well, 1 is obviously, it's a kind of fixnum, and what do fixnums know? They know all these things, and on that list you can see this. And so plus is a method, and this is what's real. right? This is the truth at the bottom of all things. You send the plus message to fix num and pass another number as argument. That special syntax, that syntax where you can say 1 plus 1, is something Metz did just for you because he wanted math to feel normal. In reality, inside, I'm just sending a message to an object. What's normal is this. This is what's real. What's special is 1 plus 1. And so on this list, you can also see that. And what is that? Well, you can do that. Now, I feel like I don't have to, I've already convinced you, I hope, that I'm sending the equal method to fix num. And when I do that, you get back this object. What is it? Well, it's the singleton instance of true class. And what does true know? It knows all this stuff. Now, true is actually a little bit more nuanced than that list indicates, but for right now, I want you to believe the useful lie. Let's assume that it's just an object like every other object, and this is what it knows. I am very comfortable with this idea. This is a very small talk-like idea. When I came to Ruby, I was completely unsurprised to find that true was an instance of some class. In Ruby, it's a singleton instance of the true class, just like false is the singleton instance of the false class, and nil is the singleton instance of the nil class. These things did not surprise me at all. But there was something that confused me when I came to Ruby, and it was that there was a special syntax for dealing with this object. A special syntax, and it's a syntax that Smalltalk did not have. This is the complete list of the Smalltalk keywords. And no matter how many times you count them, there will still be only 6. It's all the keywords in Smalltalk. This is most of the keywords in Ruby. And if you look on this list, what you'll notice is that special syntax for dealing with that Boolean object. Now, we take this syntax so for granted that I'm going to try to explain it. And the explanation is going to sound extremely awkward because you don't even question the syntax. But here I'm going to try, right? Here's how it works. Here's how that keyword works. It takes an object, in this case, an instance of true, because that's what it evaluates to. And if the object evaluates to true, it then evaluates the block of code before the else. And if the object evaluates to false, it then evaluates the block of code after the else. Now, of course, and you get that back, right? Now, that's a little bit wrong, because really in Ruby we have, sorry, I did that. That's what happens when I stray from my speaker notes. I'm going to keep on standing out here, just bear with me. In Ruby, we really have truthy, all right? So really what it's saying is if it evaluates to something that's truthy, I will then evaluate whatever the block is here, or I'll evaluate whatever the block is there. And so this is really saying, if you're some object whose type I know, this is a type check. And we don't do type checks in object-oriented design. The presence of these if statements is what causes conditionals cause a lot of the problems in object-oriented design. I don't want to have conditionals. What I want to do is I just want to send a message to an object. I don't want to have to look at something and make a decision and choose what behavior to supply. I want to have an object that I can just then send a message to. If you came to Ruby and to object-oriented design from a procedural language, any of them, where you wrote a lot of conditions, if you came to Ruby from a procedural language like that, then you can get trapped into a procedural mindset, and it prevents you from using the power of objects. And I believe that this keyword holds us back. And so to prove to you how unnecessary this keyword is, I'm going to replace it. I'm going to write message sending syntax in Ruby that means we do not need this keyword. All right? Let's do it. It's really easy. First, we'll break open true class. I'm going to monkey patch true class. Why not? And there's a new API. It's the message if true or the message if false, all right? So true class, this takes advantage of the fact that Ruby methods take an implicit block. So in the if true method of true class, I will yield to the block, and then we're just going to return self. Don't worry about that for now. You'll see why in a minute. The if false method in true class does nothing. It does not yield to the block. It just returns self. All right? That takes care of true. How does false work? Well, it's just the opposite, right? False, true yields when it's in the if true message, and false yields when it gets sent if false. And so if you do this, if you're willing to break into those classes on Monkey Patch, really fundamental-based classes in that way, then you can do this. All right, that evaluates it true. I send the if true message to it. Sorry, here, I'm going to keep on messing with this. Now, remember, it yields to the block, so I get this back. If I send if false to it, it does nothing. All right, the opposite happens here. If I send if true to false, it ignores the block. And if I send if false to false, it will yield to the block. All right, now, that only does true and false. And in Ruby, we actually have truthy and falsy. And that's really easy to fix. Now that you've gotten here, I'm just going to promote that up into object and duplicate this code in nil class. All right, and if you do that, now you can do this. Everything is true, and nil and false are both false. And that means you can replace this code. Instead of writing this code in Ruby, you can send a message. And now you can see why I return self, so I can chain them together. And instead of doing this, you can do that. So that special syntax is completely unnecessary. You can do everything you need to do in Ruby by sending messages to objects. Now, having shown you this, I am not suggesting that we do it. I don't want to do it. I don't want you to tweet that we should do it. I don't want you to ask Metz to do it. I don't want you to talk to the Ruby core team about doing it. It's kind of nice to have that syntax when you need it. But what I want you to do is think about how would your thoughts about objects have changed if you had never seen the if statement. If, like me, you had grown up in Smalltalk where all you could do was send a message in an object, how would you feel about conditionals? I can tell you how I feel about conditionals, having grown up in Smalltalk. I hate them. I absolutely hate them. I'm extremely condition averse. And I'm going to show you a condition to which I am very averse. All right, let's imagine here I have an animal that has a factory method find, takes an argument that's like an ID, and it returns an animal. If it can find that ID, it returns an animal. If you pass it an ID that it doesn't know, it returns nil. This may remind you of something that shall remain unnamed, that's in active record. Sorry. All right, so perhaps someone passes you an array of IDs. Maybe you don't even know what's in this array, right? You get an array from someone else. You call animal find for each of those IDs. You get back this list, and you start sending messages to those objects, right? The first one works, and then kaboom, it blows up. Now, before I go on, I want to concede that sometimes nil means nothing. It does. Sometimes it means nothing. And if that's true, if you don't care, if you don't intend to talk to the nil, right here, you should compact this array. You should throw the nils away, in which case you get objects back, and they all know name, and this totally works. However, if you need to send it a message, if you plan to send a message, that nil is something. And in that case, you have to fix it. You have to fix it right here. And very often what happens, here's what happens. The easiest thing to imagine doing is putting a conditional right there. And that conditional, one of the broadest forms of it looks like this. All right? This is what happens in your views when you say user, if user, then, right? You check to see if there's a user and you send it the name message. You want to put Sandi Metz is logged in or say guest. And you put that trap right in your views where you're dealing with that nil that came back from active record where you don't have an object there. This is that problem exactly, right? Now, this totally works. I can say no animal. I can substitute here at the caller. I can fix it and say no animal instead. But of course, we're Ruby programmers, and that's way too ugly. We would never actually write that code. We might do something instead like this. We would use truthy, right? If there's an animal, then I will short circuit it and return nil, basically here, or otherwise I'm going to send it the name message. And when you do this, what happens is I can no longer get no name back right here. I'm forced to just accept this empty string. Of course, and now we're Rails programmers, and so we got try. You got try, right? And so this is what you do here. You'd say that, animal try name. And I'm not hating on try. I use try myself. I'm not saying try is bad, but I want to be honest and clear about what's going on here, right? It covers up a problem that you should fix in another way. So here again, I have to get an empty string back. And so really I got that, and let's just talk about what this really is, right? It's really that, which is really this. It's a check for an equality against nil, the instance variable nil, which is really a type check on nil class. And if you write it all out, if you take the ternary out, you get this. And that is really, well, and here, it's really worse because I want to substitute a value in there. And that is really this, which is what I was hating on in the first half. Right? This is what I told you I absolutely hate. But here it's actually even worse because what we're saying is if I know the kind of thing you are, I will supply the behavior. Otherwise, I'll send a message to that object. This is crazy talk. The problem with this is that conditions always get worse. They always get worse. And here you know the condition and you know that string no animal, and you have it spreads out all over your app. And then eventually a day will come when you need to change it, and the thing that happens at that point is a code smell called shotgun surgery. Right? There's a single concept that's duplicated all over, and you have to make one change, you have to edit code in many places. I hate this idea. It's a maintenance nightmare, and so I am extremely condition averse. What I am instead is message centric. I don't want to know things. I just want to send a message to an object. And the problem with this code, the problem here, sometimes I get back an sometimes I get back an object that responds to name, and sometimes I don't. The objects that get returned from this method call, from the animal find method call, conform to different APIs. What I want is to send that message, but the problem is some of the objects I get back don't understand it. And so here, animals do. Animals know name. That's fine. That's not the problem. The problem is nil doesn't. And what I really need, to get rid of the conditional, what I need is some object that can do this. If I send it the name message, I want to send a polymorphic name message and have it return the string that I want. And so let's just program by wishful thinking. Let's write the code we wish we had. And so the code I wish I had that. I wish I had that. And so what I could do, all right, let me back up. So what happens, again, when I walk out here so I can see you, I get distracted from my nodes. So I would rather know the name of another class than duplicate behavior. Always. I'd rather know about another object than have a duplication of behavior. And so once you can think of making that missing animal object, you can put it right there. Absolutely right there. I can use bar and substitute it in. Now, if I do that, I get this, and then everything works. And so what just happened? Well, okay, I added a brand new dependency, and I still have the conditional, but there is an improvement here, and it's that I no longer own that behavior. And since I don't own that behavior over here, the calling code, all of that goes away, and I can do this, and then finally that. And so, and it all works. I get the right answers back. So this technique, where you make a new object and you swap it in for nil, it has a name. Does anybody know the name? Oh, shut up, Caleb. He's seen the talk. Is anybody else? Yeah, the null object pattern. All right, and there's somebody in Joshua Karievsky's book, Refactoring to Patterns, he quotes a guy named Bruce Anderson as calling it the active nothing. It's like a beautiful term, right? The active nothing. Okay, so the truth is here, so I've swapped knowing the behavior for knowing the name of an object, but I still have that problem. I still have this new dependency. And so I told you that I'd rather know about an object than duplicate behavior, but it's also true that I don't want to know about very many objects. And the problem we had a minute ago with the no name, the conditional going everywhere, well, now we just treated it for a new problem, right? Now I know missing animal in a bunch of places. But once you get here, this is really easy to fix because you can take that untrustworthy external API, the API that returns objects that conform to different protocols, and you can wrap it in your own class. And in your own class, you do the translation. You put the conditional in this one place. And then if you go back in the calling code, all the other places in your application, you swap the conditional for a send to your own trustworthy wrapper. If you think of animal.find as an interface, I think of this wrapping class as the outer face. It's the funnel where everything that comes out of your application gets converted as it jumps over. It gets fixed in this one place. So even though I hate conditionals, the sad truth is you can't really get rid of them completely. You have to, someone has to know, and they have to fix it, but you should strive to fix it, push the change to the boundaries of your system, and have that conditional be only in one place. So if you do that, you'll get these back, and you do that, and it all works. Okay, so this is an improvement in the code, and it comes from being message-centric. The null object pattern is totally awesome. But what I've learned in the last 18 months is that as awesome as it is, it's a very tiny, small, concrete instance of a much larger pattern. And now, the talk is going to get more abstract from this point. If I lose you, I'm not saying I will, but if I do, remember the null object pattern. If you use it, it will make your life better. But now I'm going to talk about the null object pattern is a concrete instance of a much larger abstraction. And I'm going to talk about how to find that abstraction. And in order to do that, I have to use a different example. And so this is a tale, a nursery rhyme that kids in the US learn. I don't know if you know it. Do you know the house that Jack built? Yeah, okay. So I'll show you. I'll give you an example, okay? So line 1 is, this is the house that Jack built. Line 2 is, this is the malt that lay in the house that Jack built. Line 3 would be, this is the rat that ate, the malt that lay in, the house that Jack built. So you can see it's a pattern. They call it a cumulative tale. So there's a new bit that gets stuck in every time and all the old bits stay. This has 12 parts. And this is the final version, the horse and the hound and the horn that belonged to the farmer sowing his corn. And I don't know why, I loved it as a child. So do you have an equivalent? Here, I'll ask you later. Think of what the equivalent would be for Spanish speakers, and I'll put it in the talk next time I give it in South America, okay? So help me out. All right. So if I ask you to write the Ruby code to produce this tale, you would probably do something like this. You'd maybe put all the bits in an array. You'd wrap that in a method. You'd maybe make a phrase method that took an argument that would get, 1 or 2 or 3 of them and put them together. You may know last on array. If you send last, it brings the last thing out. But if you pass an argument, it returns you an array of that number of things. So in the case of 3, I would get this back. I need a thing to produce a whole line to put the this is on the front and the period at the end, so I'd have a line method. I want to recite the whole tale, so this loops 12 times and calls line on the numbers 1 through 12. And then I would wrap that whole thing in a class. If you write this code, it works. If you ask for line 1, you see that, line 2 that, line 3 that, line 12 that, and if you send a recite, you see the whole song. So your customer asks for the house that Jack built feature, and you write this code. And of course, you do it so well and so efficiently and so quickly that the next thing that happens is they ask for something new. And what they ask for is they want you to keep house. We can't change house. But here's the new requirement, something called random house. Right? What they want is for the very first time, in the very beginning, when you start to produce a tale, before you produce any lines, they want you to randomize this array. And then they want you to produce all 12 lines based on this new cached copy of the mixed up array. If I were to, like in this case, again, it's different every time. If you random it, in this case, it would end the cat that killed, the maiden all for one that milked, the rat that ate. That's how the song would end. The tale would end. So it looks like that. I want that, and here's how 12 looks. Now, you guys all have way better English than I have Spanish. So you may have already noticed that some randomized versions of this child's tale are a little not safe for work. It's different every time. It's an equal opportunity offender, right? There's something here for everyone. And so how would you do that? And so I'm going to put 2 constraints on you, right? I want you to, well, 1 constraint for right now, 1 constraint. I want you to do this, but you can't use an if statement. You can't, I need house. House has to continue to work. And I want you to write random house without putting an if statement. How would you do that? There's one really very straightforward, obvious solution, and it's to use inheritance. Inheritance is awesome. Look, that fast. It's done. I can subclass house. I can override data. You may or may not know that shuffle is the method on array that randomizes the contents. And because I want to shuffle it once and use the shuffled version for all the lines, I have to cache it. And so if you do that, this, 1, 2, 3, 4, 5 lines of code and 2 minutes of coding meets this new requirement. If you look in there, the priest is marrying the man that's kissing the horse. All right? Okay, that was perfect, right? This is why people love inheritance. Inheritance is a great solution for this problem initially. And so what's the next thing that happens? After you did house and you did random house in about 2 minutes, yeah, they asked for another feature, right? And here's the next requirement. It's called echo house. Here's how echo house works. It's this echo effect. This is the house that Jack built, the house that Jack built. The multi-land, the house that Jack built, the house, all right? It goes like this. Now, you have to keep house, you have to keep random house, but now I also want echo house. How are you going to do it? Now, I submit to you that it's this bit of code right here. I could kill myself. I also live in terror of falling down on stage. I've never done it, but I worry. So this bit, it turns out this method has more than one responsibility, right? It gets the things out of the array here. I'm just going to go back over here. I have a pointer. I can do that. It gets the things out of the array, and then it strings them all together. So I'm going to do a tiny bit of refactoring before we go to make the change I'm about to do easy. So I'm going to pull that out, and I'm going to extract that into its own method. So I'm going to call it parts, because names are hard, and then we don't care about phrase anymore. And so right now, the current version of this gives you that. If the number were 3, I would get those 3 things back. If I could instead get this back, echo house would work. And so what are you going to do? How are you going to do it? Of course, you're not allowed to use an if statement. It's really easy. There's a really obvious, easy solution here that means inheritance. And sure, we're going to use inheritance at this point because you already did, right? That you're going to follow the pattern that we have. And it's so easy. It's no wonder inheritance is attractive, right? I'm going to override parts. I'm going to call super twice and zip them together. Zip is not compress on array. Zip is zipper. Zipper. And so here, calling super twice gives me those. So that gives me this back. Now, join works even though it's a 2-dimensional array, but I can't stand that, so I had to call flatten on it because it just bothered me. And maybe that's a flaw in me, probably, right? And so so that flattens it, and then this totally works, right? I have echo house. All right, so here's the code we have right now. I got this. Random house is overriding data. Echo house is overriding parts. Everything totally works. And we did it in just a few minutes. Can anybody guess? New requirement, what is it? Random echo house. Yeah. All right, and now I'm not going to now I'm going to give you the second requirement, right? You can't use a conditional, and you may not duplicate code. And now you're screwed. You're absolutely screwed. This is how inheritance goes wrong. Let's look at it. We don't even care about house. House does not matter. That is not where the problem is, right? Here, I have no choice. If I want to continue on down the path of inheritance, I must duplicate some code. Either I can subclass random house and inherit data and duplicate parts, or I can flip-flop it. I can do the opposite. It's no better, right? I can inherit parts, and I can duplicate data. There is no other choice here. Now, and sometimes when I go, now I travel and I look at people's code. That's how I make a living. And when I see this problem, it's really common. If you have this problem, you should not feel bad. Everyone has this problem. When I see this problem, what happens very often is instead of duplicating some of the code, they just duplicate all the code, right? They do this. And I am sympathetic to this. There's a way in which it's more honest to just duplicate all the code because it doesn't really belong on either side of this one side or the other, right? And so now you're going down that inheritance path that involves lots of duplication, and things have gone so badly wrong that it was fast and it was perfect, and it went to hell just with one new requirement. And I have a picture really to help you visualize what's going on. So we had house. It feels like, okay, I can't stand it. I'm going to carefully walk over here. It feels like random house and echo house are tiny. Right? It feels like we just did a little bit, but really, they're all of the things that are in their superclass, including that bit that they didn't specialize. And the same with echo house. It's really big. It's much bigger than it feels. It inherits a bunch of methods from its superclass. And so we don't even really care about house. We're dealing with objects of this size. And once you get here, if you want to inherit random echo house, you can get the specialization that's in its superclass, but you cannot get that. And if you put it on the other side, it's no better, right? You inherit that, and you don't get that. And I'm going to just do that last one more time because I want you to appreciate how cool Keynote is. That is very cool. Okay, and so what we want is some kind of multiple inheritance. And very often at this point, someone will suggest modules. Modules is just a form of inheritance. It is not the solution for this problem. If you write the code to implement this in modules, it will go badly wrong just one step later, one step after the inheritance one, right? So we're not going to do any of this. So what we know is that random house and echo house specialize a very small percentage of the superclass, and they share a lot of the code. And that is the wrong use of inheritance. So it's for specialization. It's not for sharing code. We talk about inheritance as being an ISA, right? And so you would have to ask yourself here, here's the question you should ask yourself. Random house, is random house a house? And if you look at this, you'd be like, well, yeah, it says house. Like right there, right? And this is a problem of bad names. Like when we're confused and then we give things bad names, the names further mislead us. And so really the best way to solve this problem, the best way to figure out what's going on is to ask yourself, what does the subclass change? What does the subclass change? And it's really hard. So now I think, yes, to the next big pro tip of this talk. This is an amazing paradox. You can make it easy to figure out how things are different by making them more alike. And so I'm going to show you, let's make this code more alike, and then it will be much more obvious in what way it is different. So I'm going to try to make the two data methods as much alike as I can make them. So here, obviously, in the top, I'm going to have to, I'll put that in a constant, and then I'm just going to define a method. And then now I have this. All right, and so I'm just going to I'm going to nibble away making very small transformations that don't change the behavior of the code. They just make it look more alike. And so I could do that. It's unnecessary, but it works, right? And it makes it more alike. And then I could do, though I'd never do this in real life, you could do that, right? You could change the super and put data there. And now, once you get to this point, you can ask the question again, what changed? And it's much easier to see. Now, if you have an idea, don't shout it out yet. All right? So you have to give it a name. You have to name the thing that changed. And this is, again, we've been led astray by the bad name. Names are the hardest thing we do. And so I had the good fortune to teach a course with Avdi Grimm. And my rule about teaching is I can't tell people things. I just, like here I'm telling you this, but in class I just ask questions. So it's really hard to ask the right questions to get people to discover these ideas. And so Avdi came up with this. He said, pretend it's a spreadsheet. Pretend you're in Excel, and you have rows and columns. At this point, you have to name every column. And so this is pretty clear that that's a class. And I suck at names, so we're going to call this data. The question is, what is that? Okay, I heard method, I heard attribute. I want something closer to the thing. So this is a concrete instance in some category of thing. Behavior's too broad. I want something closer to where we are. Order. Yeah, we called it random house, but it's not. Randomness is not what changes. Randomness is a kind of thing in the category of order. Now, once you can figure out what the name of the thing that changed is, what you know is that that isn't nothing. There's no code for this in my class, but this means something. This is an algorithm for ordering, and it's just as valid as this one. It's a real thing. And so at this point, now that you know you're dealing with order, if you ask the question, is order a house? It is so not a house. right? And so now we know what to do. It's a role. Let's write, we have 2 order roles. Let's write the code for them. Here's one. This one's pretty easy to imagine, right? This is the random order. I had to name it. I had to name the role, and I had to pick an API. I decided it was going to take the order message, right? And it's going to shuffle the data. This is not the one that's hard to think about. Paradoxically, this is the one that's hard to think about. What does this do? Well, it's not nothing. It's such a hard thing, isn't it? It leaves the order unchanged. That's its algorithm. All right? And so if you can think of these 2 things, I don't even need this inheritance. I'm just throwing that away. And I'm going to go ahead and put an attr reader in here for data and get rid of that to make this a little easier. And we don't need that anymore. OK. And so now I'm going to take, now that I have these 2 objects, I'm going to remove the responsibility for ordering from house. And we'll do that by injecting. I'm going to invert the dependencies and inject one. The technique I'm going to use to invert the dependencies is dependency injection. I'm going to inject the dependency, and I'm going to have this thing put it in order. All right, and this works. And so what have I done? I have more code to do exactly the same thing. All right? This is why people complain about object-oriented design. Right? And rightfully so, but watch this. As soon as you need the role, you should inject it. And I can promise you in class, there's a bunch more players of this role, right? I have order after order after order, and you can make an infinite number of new ones and plug them in with dependency injection just that fast. And now that you have this idea, how would you do echo house? Oh, sorry, wait, there we go. That's proof that it's right. This is composition. I'm going to inject an object to play the role of the thing that varies. How do you do the other one? It's really easy now that you've seen one. I got this one, right? This one, and again, this one's easy to conceive of because this code came out of the original subclass. But now you need to put code in the other one, which is that. It's an algorithm that says, I will not change parts. It's as valid as the other one. And if you do that, then here, I'm going to inject it. Now, I shoved it. When I used it, I'm just going to save it. And then I put it way down here, because I wanted to intervene at the last possible place, because I'm scared. Everything I do breaks something. So I was trying to intervene at the lowest place possible. You could be forgiven if you wanted to put this at some other place in the class. But so I'm going to format it right down there after I pick the set in parts. And so here, again, I've added more code to have the same original behavior that I had. This house still works the same, but I have to have both of these, an object, 2 objects, one to play each of these roles. But now I can use the echo formatter, and I can just plug it in there. I can inject this dependency, and it just works. So now we've made 2 new roles. We've made this orderer role and a formatter role. And I'm going to go just recite the whole thing. I can do that. I can do regular house. I can do random house. I can do echo house. And I can do echo random house. And I don't have more code. And I don't have any duplication. This is pluggable behavior. This is what it means to do composition. Now, here's the picture we had originally where we had inheritance. And I'm going to show you what composition looks like. This is how it should feel in your head. So instead of that, I made a new object for each of them. And the key thought here is that you got to get this out. You have 2. You don't just have one. You have this one, and you have that one. So you have to pull them out. You have to isolate the thing that varies. And you have to give that concept a name. That leaves a hole inside this object. It no longer works unless you inject one of those dependencies. In this case, when we named them, we called them order and format. You have to define players of the roles. We called them orderers and formatters. And then at runtime, you have to inject the player. You want to see that again, I'm sure, right? Here, it is like one of the few consolations of making long slide decks, doing ridiculous things in Keynote. And so this is composition and dependency injection. And this is what it means. to do object-oriented design. So, understanding these techniques lets you choose to use them in appropriate circumstances, and it means that you can improve your code. Being able to see the underlying abstraction lets you get the abstractions correct, so you're not chasing after the wrong things. So, first, if you're talking to nil, if you're sending messages to nil, it's something. Don't check for nil in a bunch of places in supply behavior. You're done with that. No more nil checks. Right? This is low-hanging fruit in your application. Your code, you can make your code much simpler to maintain if you just go find the things that you check for nil the most often and make 1 or 2 null objects. There's very good documentation about how to do this in Martin Fowler's refactoring book. So you can save yourself a bunch of conditionals by using the null object pattern. Make active nothings. They'll make everything easier. Next, be careful about inheritance. Now, I'm not saying that inheritance is bad. I love inheritance, and I can tell you this. If I only had those first 2 requirements, I would use inheritance and walk away. It's cheap, it's fast, it's easy. Like, there's no reason to use composition and overcomplicate this problem if inheritance will work. But as soon as inheritance starts failing you, as soon as you hit resistance, you need to turn to composition. There's no such thing as one specialization, and that's what composition relies on. If you inherited it and changed something, the other thing is that piece that's left up in the class. In order to use composition, you have to isolate the thing that varies, give that concept a name, define the role, and then inject the players. This is incredibly easy. It's incredibly easy once you see it, but in order to see it, you have to believe in nothing. When you first got started in OO, back when you first started writing object-oriented code, it was really easy to think about modeling real-world objects, making classes for real-world things, the chair that you're sitting in, right? The person that's beside you. And then you don't have to write code very long before you realize that you can model ideas. You can model business rules and concepts and like business procedures. Back in the very beginning of this talk, I started out talking about fixed nums and Booleans. And you cannot reach out in the real world and pick up a 6 or a true. Yet in our applications, they're real. They're as real to our, there's real to the OO code we write as the chair or the person. And as abstract as numbers are, there's a way to double up on the abstraction. It's the idea of the number 0, right? Before, there are many, many counting systems that didn't, when we didn't have the idea of 0, here's how arithmetic worked. You would say, add these 2 numbers unless one is 0, in which case you do a different thing. There's the conditional, right? There was a set, this is exactly how your code looks. There was a set where the nothing in that set did not have a symbol. And when they made a symbol to represent the nothing in the set, they turned numbers into what we would call polymorphic, so that they could use them all to mean the same thing. Before 0 existed, we had a gap in our ability to imagine the world. And after they thought up 0, the world got, paradoxically, both way more abstract and way easier to deal with, way simpler. Your applications are full of ideas just like 0. They're abstractions that reveal their presence by the absence of code. I don't want to write a conditional, I just want to send a message to an object. And in order to do that, I have to have somewhere to send it. And you have to find that object, and it might be hidden in the space between the lines of your code. And that thing you need to find may look like nothing, but it can't be nothing. It's never nothing, because nothing is always something. Thank you. I'm Sandi Metz.